Right, so we've got two lines with two equations. The first equation, we've got all the information. 2x plus 4y minus 3 equals 0. Remember, any sort of algebraic equation with x's and y's but without any squares or cubes or anything added together, separate terms for x, y and a number added together, must always be a straight line when you do the graph of it. Y equals mx plus c in the form y equals mx plus c of an equation, but they've given us c is 7, but they haven't actually told us what m is, and that's what we have to find in part A, because it tells us that L1 and L2 are perpendicular. Now that means, if they're perpendicular, it means the gradient of the first line multiplied by the gradient of the second line must equal minus 1. Okay, that's a fact which you will be often using in A-level maths. So the product of the gradients must equal minus 1, and although we just called it m, I can put a 2 there to emphasize that what we're calling m2 is actually this m in this as the gradient of the second line. Right, so the first thing to do is to work out what the gradient of L1 is, and to do that, what we're going to have to do is just rearrange the formula to get it in the form y equals mx plus c. So we've got 2x plus 4y minus 3 is 0. 4y is going to equal minus 2x plus 3. Divide left and right hand side by 4. We get y equals minus 2 over 4, which is minus a half x plus 3 over 4. Now that tells us that the gradient of the first line, m1, must equal minus a half. Right, now, if the gradient of the first line is minus a half, then you can just say straight away, well, m2 must be the negative reciprocal. So m2 must just equal 2, because we turn minus a half upside down and we get the 2 on the top, but then we've got to change the sign. But I'll just show you how that works. I'll just do it algebraically as well. m1 is minus a half times m2 must equal minus 1. If we times both sides by a minus, we get a half m2 equals 1, and then m2 is going to equal what we get if we times both sides by 2. Well, 2 times a half leaves us with m2, and 2 times 1 is obviously just 2. So, but a quick way to do it is to just turn the fraction upside down and change the sign, and that'll tell you what the gradient of the second line is, and therefore m equals 2. Okay, so we've done part A. We found that the gradient of the second line is equal to 2. We found the value of m, and we know the equation. The equation of the line is just going to be, I could write it, I suppose. The equation of line L2 is y equals 2x plus 7. Now, it then tells us in part B that the lines meet at the point P. So they intersect, and we need to find the x-coordinate of P. Where you've got two lines, where they intersect, we get the x value by solving the two equations simultaneously, because where the lines meet or intersect, they must have the same x and y values. So the equations for y, for both of them, must be equal at that same x point. So in other words, what we can do is, for part B, we can just solve the equation that the first line, we've already done the first line in terms of y equals mx plus c, and we've got minus a half x plus 3/4. That has got to be equal to the equation for the second line, in the form mx plus c. So that's going to equal 2x plus 7. By solving this equation, we can then find what the value of x is where they meet. Or we can, in other words, we can actually find the intersection point of the two lines. So how can we solve this equation? Well, yeah, I mean, I'll show you one way to solve it. If we times both sides by 4, that's going to give us minus 2x plus 3 equals 8x plus 28, which means that if we move the numbers over to one side, so 3 minus 28 is minus 25, 8x plus 2x is 10x, so we end up with x equals minus 25 over 10, which is minus 2.5. So we've done it. Now some people might want to do it a slightly different algebraic way. What you could do is you could, rather than use the converted form of the first equation, you could just substitute our y value, our y expression into the equation for L1. We'll get exactly the same answer, but that will give us workings like this: 2x plus 4y, but we know that y from the other equation is 2x plus 7. And I think the equation was minus 3 equals 0. Yes. So then if we solve this, it should give us exactly the same answer. 2x plus 8x plus 28 minus 3 equals 0, and we get exactly the same again. 10x equals minus 25, so x is minus 2.5.